तेरा मेरा सफर अरे यार तेरा मेरा सफर आए जो गुजरे Okay, so I hope it is visible to everyone. Um, okay, so good evening, everyone. I am Archita. I am a PMRF scholar at ISO Kolkata. So this is an interactive session for NPTEL course NPTEL course Air Pollution and Control. This is an interactive session for week 7. Before I begin, we'll take one question from the last week, which was doubt, and then we'll go ahead with this week's questions. Now, most of the lectures for this week are about indoor pollution. What are the modeling methods for indoor pollutions? Um, what are different sources, and um, what are different approach towards that? So let's begin. So this question was doubt in the last week's class. So here, what was given is that two different sources are given. Okay, so two sources are given: soil and steel plant, and to the concentration or the effect of two metals need to be we need to understand the effect of these two metals, which is calcium and iron. Okay, so their concentration in the ambient air is 50 microgram and 15 microgram per meter cube, and we have to calculate the pollution contribution of each sources in the ambient area. Okay, so for that so this is mass balance equation will be used, because we know that the emission inventories work on the principle of conservation of mass. So here what they did is that concentration, x is concentration, so concentration of any element is equals to the fraction by that element, uh, uh, the emission fraction multiplied by the amount that it can affect, right? And same for soil, that what is the fraction of soil has calcium multiplied by the fraction that of soil that can affect, right? So if we look at these two equations, we know xc and xfe, which is 50 and 15. Then we know what is the fraction, contributing fraction or the emission fraction for each component, for each steel and soil. So this is 0.2, Okay, this F soil is zero point 0.9 for calcium. Now GFE steel is zero point 0.8 and this is zero point 0.1. Now what you solve is let's I will call this as A and this as B. So the equation becomes okay, 50 equals to 0.2A plus zero point 0.9B and 15 equals zero point 0.8A plus zero point 0.1B. Now if you solve the first equation, let's find the value of A. So for equation 1, A is equals to 50 minus zero point 0.9B divided by zero point 0.2, right? Now since F steel, the fraction of steel that could be harmful or the fraction of in soil that could be harmful, these are constant. A and B are constant. So what we'll do is we put take this A and put it in equation number 2. Okay, and when you do that, you can find the value of A and B. So this equation, when you solve it, you get value of B, and similarly the value, if whatever you get for B, you put it in this and you get A. So that A and B is the pollution contribution of each of the sources in the ambient area. Okay, so it's as simple as this, because what you do is you make simple mass balance equation based on the concept of conservation of mass. If you have any question about it, you can ask. Otherwise, we'll go ahead. Okay. So let's go ahead. Other other now we move towards the question about indoor pollution. These are simple questions. So first question is that which air pollutant or indoor air pollutant cause formation of carboxyhemoglobin. So carboxyhemoglobin is nothing but when this carbon monoxide attached to the hemoglobin, which is nothing but iron, right? So when they attach together, they obstruct the or decrease the oxygen carrying capacity of blood. And why CO is even harmful? Because we have seen in the last lectures that CO is also silent killer because of it, because it doesn't have taste or odor, so you can't even identify if there is any emission of CO or not. Okay. Next is that which pollutant will result in pulmonary edema. So pulmonary edema is nothing but the when lungs are filled with fluid, and it is caused due to the NO2 emission or NO2 pollution. Next question is the how the particle size affect the deposition, right? So we know that uh, so this is a nasal passage, then there is trachea, and then from trachea there are a lot of bronchi, and they enter lungs. So the bigger the particle, the smaller the particle, the farthest it will travel, right? So the bigger particles, let's say if I start with PM10, so PM10, PM9, PM8, like that, and the smallest particle, for example PM less less than 1, they will deposit in the alveoli, which are nothing but air sacs in the uh, lungs. Okay, so the smaller the particle, the farthest it will travel and the more harmful it will be. So how that is how you need to understand to make amendments regarding the particle size. Okay. Next is about the HEPA filters. So, in the lectures, it was said that in to control pollution, indoor air pollution, and especially from asbestos, they generally use this something called HEPA vacuum. So, HEPA vacuums are nothing but vacuum units which has HEPA filter. HEPA is air filter which are very highly efficient, and so there are some filters with efficiency of, let's say, 50%. Okay, so 50% efficiency means that if I am saying that my filter has a pore size of zero point 0.3 micron, then and it has an efficiency of 50%, what I'm trying to say is that it can collect particle with the size um, with size of zero point 0.3 micron or less with the efficiency of 50%. That means 50% particles are collected and other 50% are being lost because of the low efficiency of the filter. But HEPA filters have very high efficiency, and and it is for a specific particle size, and so it has a 99.9% efficiency for zero point 0.3 micron size particles, and they are very very sensitive and very reliable. That's why in industries HEPA filters are generally used, and similarly HEPA vacuums are used if you live in place where there are a lot of asbestos pollution from the ceilings or those teens that you call okay. Now, next question is about the critical concentration of formaldehyde. So, the formaldehyde pollution can cause something called watery eyes or redness and lungs infection, all of that. So, uh, and it is so much that like a zero point 0.1 ppm concentration is harmful. Okay, zero point 0.1 ppm is 1 by 1 million. Okay, so even this small concentration of formaldehyde could be really harmful. So this is the critical concentration of formaldehyde. And similar to this NO2, there is similar to carbon monoxide, there is another pollutant which reduces the oxygen carrying capacity of blood, and that is lead. And from indoor air pollution, especially if you don't use um proper what do you call proper paint, or for example these days there are lead free paints and all these things. So if you don't use proper protective mask if you are going outside, or if even if you are in indoors and you don't have proper paints or proper ventilation, then lead pollution is really harmful. Okay. mm, let's move. Okay. So another is radon mitigation system. So radon, if you remember in the last class, I said that radon comes from soil. Okay, so sometimes there are certain types of soil which has radon gas and they release radon gas. So in certain regions there is are more prone to have radon pollution, and on in those region it is generally advised to have radon mitigation system in houses to avoid any sort of air pollution caused death, right? So this radon mitigation system has different factors to it. So for example, it has a gas permeable layer, plastic sheeting, then ceiling and vent pipe and junction box. So and the names are given in this picture. So this gas permeable layer is nothing but it's like a layer of rubles or the boulders below the housing, to allow the gas to be released, right? So if there are bigger chunks of particles, okay, then gas will easily released or will emit from the pore spaces. So that is what this gas permeable layer is. It allows the easy escape or flow of gas. Okay. um, Next is plastic sheeting. Now plastic sheeting is required because if the gas we don't want the gas to enter house, right? So this plastic sheeting is the barrier which makes sure that even though the gas is easily flowing in this gas permeable layer, it will not enter the houses. And to make sure that it is like a very fixed thing, what they do is that they provide seal around this vent. So what they are doing is that they have a gas permeable layer, and then they have this pole sort of structure which helps the gas to escape. Okay, and over it they have this plastic sheet so that the gas will not enter any house, and only it the only route of escape is through this vent pipe, and it will go into the atmosphere, right? So that way the indoor environment will be radon free, or they will not have any radon pollution. Okay, and junction box is nothing but it hold that pole on the roof. Okay, so these are the different components of radon mitigation system. Now we know that the pollutants that are there in the atmosphere, somehow we all of us are being exposed to them. So to understand the like what factor does the exposure of pollutant depends, we need to know a few things, and this equation is what tells us that we need to know the concentration, right? So this picture is not very clear, but okay. So factors to understand the exposure of pollutant are the exposure factors, time, and concentration. So concentration will help us understand that in a particular region how much emission of a particular pollutant is happening. Okay, for example, in a remote or a rural location, the concentration of PM or nitrate or SO2 would be very less compared to an urban location, right? Similarly, exposure factor means that what how much population is affecting, which sort of population is affecting. So only old people are getting affected, or childrens are getting affected, or the population is mixed, or for example the different economies are affecting. For example, rich people are getting affected, or the poor people or the below poverty line people are getting affected. So you need to understand the exposure factor of a particular pollutant. Okay, then time, that for what time it is being exposed to, and all of these factors will help us understand that a particular person, how much it is getting exposed to a certain pollutant. Okay, so these three factors are important, which is concentration of a pollutant, exposure factor of the pollutant, and the time for which it will be exposed. Okay, now we move towards the next lectures. Okay, so next is the various type of sampling designs. So sampling designs are that if let's say if I am studying about indoor pollution, then how we need to proceed or how we should proceed. So there are four different types of sampling design that are being studied. One is simple random, another is stratified random, then systematic and cluster sampling. So, cluster sampling is the simplest. Cluster sampling means when you don't study individual, you study a community. Okay, you study a particular geographic region. Okay, for example, that if you live in you live in Delhi, and you are studying for indoor pollution, you are studying a particular location of Delhi. For example, let's say Rajiv Chowk or Anand Vihar. Okay, so that is cluster sampling. Next is the next we'll start from simple random. Simple random means that you take random individuals in a particular bunch. Okay, So let's say I am studying, again, let's say a particular location, let's say Anand Vihar in Delhi. And simple random means that irrespective of age or um, or gender or health condition, I am selecting random individual. Okay, that is simple random, that you select random people of a particular bunch to study about their indoor pollution, about effect of indoor pollution. Next is stratified random. Stratified random means that you select a particular strata. Okay, for example, I chose to study only men, that how indoor pollution is affecting men. Or if I chose to study only children's, or uh, if I chose to study a particular age group, let's say I am in a particular region, I am studying only people who are between 20 to 30 years. That is stratified random, that in a random population you have, you are making a strata of a particular age group or a particular type. Then systematic is that you create an order, that okay, let's say I am going to study 10 men. Okay, then 5 women, then I will again, after 5 women, I will again come to the 10 men. So when there is a repetition after every kth element, that is systematic. So you, in a population, you want to study different fraction. Okay, but you are making sure that after every one after every kth element there is a repetition. That is systematic sampling design. Okay, now we need to, next question is about the active and passive sampling difference. Okay, so active sampling, as the name says, active means that when you are doing something very vigorously, okay, or you need a push to do sampling. Passive means when you don't need a push or power to do sampling. For example, um, okay, let's say in a I am collecting samples in a particular location, and what I am collecting is that I have a low volume sampler which collect the PM 2.5 samples. Okay. So every day I go at 7 a.m. I put the filter, and then at 7 p.m. night I collect the filter. The next day I'll go. It runs on this it has a fixed volume, it has a fixed time period to run, and it has a power supply. Okay, so with the help of the power supply or with the help of the machine, it is sucking the air, getting the particle deposited on the filter, and escaping the air out. That is the active sampling, when a rigorous process is happening to collect something. Passive sampling is, let's say I want to collect plastic, so on a roadside, for example. So what I'll do is, I take a container, let's say I have a tray, and then I go and put that tray on a platform just beside a highway. So I am doing nothing. I have just kept the tray there for a couple of hours or for a day, and I'm letting the particles naturally settle on the tray. That is passive sampling. It means that we are not putting effort, or we are not doing something rigorously to collect pollutant or to collect any sample. The samples or the particles are being collected themselves with the effect of gravity or nature, whatever you call it, but you are not putting any effort to it. In active sampling, you have to put samplers, you have to make a schedule, it need to have pump which take the air in and put the air out, whatever. So that is the difference. um, Active sampling is generally preferred because there you have control over the amount of volume of air that goes in and comes out, over the time schedule, and over the size selectivity, that what sort of particles will settle and what sort of particles will be excluded or get out with the air. In passive samplings you don't have any sense of volume. You don't you don't have any size selectivity. If I put a tray just beside a highway on a platform, then every particle in the atmosphere, irrespective of size, if it has a density, or if um or by the effect of gravity it has to settle, it will settle. Okay, so size selectivity will reduce in passive sampling. So all these method have their pros and cons. Mm, okay. Now next is the difference between the direct and indirect approach of assessment. Now in terms of every pollutant, for example, is even if it's carbon monoxide, it's NO2, it's SO2, whatever, you can have a direct approach to understand it, and you can have an indirect approach to understand the pollution by a specific pollutant. Now the difference between direct and indirect approaches, that direct approach means that you have samplers, you have monitoring stations, you have the entire modeling system to understand that, okay, for example, so direct approach can also be called as very, these can have both active and passive sampling to it. Okay, so for example, I run a sample for 24 hours, and then analyze the sample for different chemical analysis, and then I have different parameters, I measure different parameters, and then put it into a model and understand that, okay, how much deposition is there for a particular pollutant, how much and for a particular region as well. So this is direct monitoring, that when you use different techniques that are there to measure it, to quantify it. Okay, indirect approach is mostly questionnaire based. It means that what I'll do is that, let's say I know that in a particular region, I have read the literature that there is a lot of pollution. Now, these organization like CPCB or um, ministries have the data that, okay, every day this much PM 2.5 is collected, all of that. You have the data. Now all you need is that you will do this survey. Okay, you go to people, you talk to them, and then you make this questionnaire and you ask them different question that, okay, have you had this sort of disease, what sort of what is your age group, how much affected you are, all of that. And then you also have the background idea, but you have not done this measurement. Okay, you have this years and years of data by the organizations. You have some questionnaires to understand that, okay, in a particular region this many people are affected, this much pollution is there. And then you try to assess that, okay, if this much people are being affected by air pollution, and in this region let's say NO2 is having high concentration, then you can say, okay, because of NO2, there could be chance that NO2 is the major driving factor towards the people who are getting affected in a particular region. So you don't have a very solid or the quantified approach towards the assessment. Okay, that is the difference between the monitoring and the questionnaire based method, or the direct and indirect approach of assessment. Okay, next question is about the techniques that are used for monitoring ventilation rate. So we have seen in the last lectures also that ventilation rate is very important, because ventilation rate will help us understand that how much air is being circulated in a particular household. Okay, and we know that there can be a natural ventilation system, there can be a mechanical ventilation system. Okay, and there can be a hybrid ventilation system. So natural is nothing but when people have these big jal sort of structure in their houses, big windows, and the air will come and go naturally without any uh, external help. Mechanical is when you have pressure like pumps and everything, or you have a circulation system in your houses, then you have the mechanical ventilation. And hybrid is that when you have both, that you can have windows which help in natural circulation, but you can also have some pumps which help in the mechanical circulation. Okay, now there are two different techniques to monitor the ventilation rate, that how much in a particular household, how much ventilation is happening. So these two are tracer gas and the equilibrium concentration method. First is, both of these method are has the same principle, which is they use tracer gas. So tracer gas is gases which you generally don't find in nature. Okay, so if, for example, if I use gases like oxygen, nitrogen, carbon dioxide, then you cannot identify that okay, how much is the gas that I have input into the house, or how much gas has entered. Okay, so tracer gas are always gases which are not present in the atmosphere. So so they both tra- techniques work on the tracer gas method. The idea is, okay, the idea is that in one of them the flow is okay, so space. So in tracer gas method, what happen is that you take this any tracer gas, a gas which is not present in the atmosphere. You have a house, okay. You put the tracer gas in the house, and then you plot something which is called time versus ln of pollutant. Okay, so you, what you do is that you fill this house with a gas. For example, let's say I am putting something called what to put, let's say methane. Okay, methane should not be, but let's say for now I'm putting methane. um, and and we wait until the entire room or house is filled with this gas. Okay, now we let other pollutant enter because the ventilation is going on, and then we see that with time how much these pollutants enter. So log, natural log of pollutant with time, and the slope of this will determine that how much is the ventilation rate. Okay, so uh, in a room you fill the room with the tracer gas, and then you let the ventilation continue, and then you see that how much displacement, basically all you need to see is how much displacement is there, uh, how much the air that is coming out or being okay, how would I say, okay, wait, I would say that how much air it has displaced. Okay, so the time this tracer gas will take to replace all the pollutant that are there in the room, okay, that will be its ventilation rate. So it changes, right? That initially the concentration of indoor pollutant was high, and over time the concentration of tracer gas will increase and the concentration of pollutants will decrease. So this slope will give us what is the ventilation rate. Now the in equilibrium concentration method, it is same. You have a room, okay, and you are filling it with a tracer gas. Now the thing is, in equilibrium concentration method, the only difference is that you fill it at a constant rate. And since you are filling it at a constant rate, you know that how much, and you wait until it reaches a steady state condition. Steady state condition is that when the concentration of tracer gas is almost equivalent to the concentration of indoor pollutant. Okay, so that is what they want, that we input the tracer gas into a system or into a room until it, with a constant rate, until it reaches steady state concentration. And then what we do is we open it. Okay, we we start the ventilation, and then we see that how much pollutants are entering and how much is going. So this is the equilibrium concentration method. Now the drawback is that in equilibrium concentration method, it is very hard to reach a steady state condition. Okay, like a condition in which you know that, okay, let's say in a particular room uh, is entirely fit, have an indoor pollutants, and I am putting tracer gas to it. Then let's say after 5 liter or 10 liter, it reaches that steady state condition. So that is why um, it's one of the drawback of equilibrium concentration. On the other hand, for tracer gas technique, you don't have a constant rate of uh, injection of the gas. So they are good and bad in their own ways, but these are the two methods that you can use or generally being used to understand that what how much ventilation is there in a particular house. Okay. Okay. Now, next question is that important functional parameter that are required or necessary to understand the indoor air quality modeling. So these are, first is source and sink. So you need to know that in a household, what are the sources of indoor air pollution? Okay, that is it paints, is it the kitchen, like is it the stove, is it if you have any chula, or is it the deodorants that you use, or is it any sort of flower pots or the plantation that you use which has a lot of pollens. So you need to know that what are the sources of indoor air pollutant. Then you also need to know the sinks. That means that, okay, let's say a very simple thing, let's say I have paint and paint release VOCs. So my, for VOC the source would be paint. Okay, now sinks would be that, let's say if somehow because of sunlight, because of ventilation, I have oxidant in the indoor environment. Now what it does is that it convert the VOCs, the oxidants present in the indoor environment will convert the VOC into something called let's say BRC, or let's say particulate matter for simpler way. So the sink would be PM. Okay, so you need to know that what are the sources of a particular air pollutant in the indoor environment, and you also need to know that what are the sinks of particular air like indoor air, indoor pollutant in a system. Okay. um, Next is that outdoor air pollutant, because in if there it's a very good ventilation in a house, in a room, then the outdoor pollutant can come inside the house. And so we need to understand that how much, what is the rate of infiltration of outdoor pollutant. And third is that exchange rate. Exchange rate is that how much indoor pollutant are going outside and how much outdoor pollutants are coming inside. If you look, then you will see that these both depend on the ventilation. Okay, so it means that even in the air quality modeling, ventilation plays a very important role to understand that how much air pollution is happening in indoor environment. Okay. So that is why it is important to also understand the ventilation rates, or to monitor the ventilation rate in a particular household. Okay. Now there are different models that have been discussed. One of them is computational field dynamic models. Now this model is nothing but it tries to understand the flow of pollutant uh, in a particular environment. So fluid dynamics means that you model that how much um, pollutants are moving from one place to another in a room or in general. Okay, now this depends on different factors or different laws. One of them is conservation of mass. Conservation of mass is nothing but whatever is entering is there, it's the mass is stable, like whatever is entering or leaving, it it is creating a balance sort of. Okay, or simply that um whatever is being generated in an indoor environment is there and is flowing. Momentum is that the hmm? Yeah, mass is conserved, yes. So momentum is that the motion is there, the particles are moving, and similarly a lighter particle has more momentum compared to a denser particle. So again, but the momentum of a particle is conserved. So it means that if two particles are colliding with each other, they are not their energy is not transferred, their momentum is not being shared. Okay, that is what conservation of momentum or conservation of energy is. So this computational fluid dynamic model works on three different uh, conservation, which is mass, momentum, and energy. Okay, if you the very important thing about any modeling technique is that you always have to keep, like, lot of assumptions will be there, so that because assumption makes like the simulation very easy. Okay, but in reality assumption does not work. So when we later modify these models, we try to make scenarios where these assumptions are not there. But in general, we have to start with assumption that there is no conservation, there will be conservation of mass, conservation of momentum, and conservation of energy. And if later we go towards a complex system, we'll realize that okay, there are certain molecules or certain pollutant which are not following any of it. Okay, or are following some of the conservation laws and not following others. So but whenever you start, or whenever you start to model any system or any pollutant, you have to start with lot of assumptions. um, okay, now next is the so after the computational fluid dynamics model, there is another technique which is simple modeling technique, which is generally used uh, to understand, like, which is simpler also to understand the indoor air pollution. So these three simple modeling techniques are analytical tool, advection, and box model. Now they are based on two criterias. uh, Generally that, let's say, uniformity or non-uniformity, you can say. So it means that if a system is well mixed or is uniform, or a system is non-uniform or not well mixed. Okay, so this simple modeling technique works on these principles. Now the analytical these three techniques are analytical tools, advection, and box model. These two works on the well mixed part. They consider that the atmosphere or the indoor air pollution or indoor environments are pollutants are well mixed. Box model works on the principle of non-uniformity or not well mixed system. Okay, now these equations you don't have to remember. I will try to make you understand, like, how these terms come, but it's not necessary for you to remember these equations. I have just put it here. Now analytical tool and advection model also works on the principle of, since I said that they work on assumption, so the assumption is conservation of mass. Okay, The difference between analytical tool and advection model is advection model works for a moving source or line source. Okay, so for example, if there is a vehicle and this vehicle is an it's a micro environment, right? And inside vehicle is also considered as indoor. So when you need to understand that in a vehicle, in a particular closed environment, how the pollution is happening, then you study the advection model. Okay, and box model is about non-uniformity, or when we are considering that it's not necessary that the pollutant inside a particular system are well mixed or are uniform. Okay, so in this, so this is the equation that is designed for analytical tool modeling technique. So what we see is that this is volume and this is velocity. So first, S is the emission rate, I think, uh, and then what you have is that you see change in the concentration with volume, and then you see that how much concentration is changing per area with a particular speed. Okay, of this speed is, I think, speed of circulation, and based on these different parameters you calculate that how much indoor air pollution is happening. So it is based on the conservation of volume and for the surface. So we see that how the concentration is changing with volume and how the concentration is changing for a particular surface, okay, or a particular region. And then you have S, which is the emission rate, and then you solve it. You don't have to remember the equation, you just have to understand that, okay, how it functions. Then advection model is for the line source or the moving source for a particular micro environment, for example a car, bus, taxi, auto, like that. Here these are a lot of, what you say, lot of terms, but they are nothing but, you all you have to do is you have to find concentration for a particular stretch, which is dx, or a particular distance. Because we know when we study the Gaussian plume model of for line source, we also um, we also defined a region which is dx. So for that region we have to understand that what is the emission rate, what is the concentration, what is the initial concentration, what is the speed, what is the initial speed, all of this. And then we can measure that for a particular stretch uh, in a car, how much concentration is there. Okay, and this is for box model. Box model, as I said, is for the non-uniform or not well mixed system. It says that the change in concentration with respect to time depends on the emission rate, change with area, how much, with what speed, how much pollutant are entering into, this is the width and height of box. So let's say this is W, this is H, this is W. So how much concentration or how much pollutant is entering minus how much pollutant is already there, and what is the emission rate per unit area for a particular area. And that will give you that how the concentration is changing with time for a particular indoor environment. Okay, so these are the three different modeling techniques that uh, we can use to understand. The most preferred one is box model, and it's the easiest one, because all you need is that you need to know that in a particular box what is the initial concentration of, if there is any pollutant, what is the initial concentration, and then what is the concentration of pollutant that is entering into a system, and what is the speed of air what is the emission rate and what is the area of this particular box, and you uh, will get a value for the change in concentration with time. And next is, in box model there are four types of mixing considered. Okay, so these four type of mixing are displacement, cavity, mixing, and piston. So let's say the difference is, as they say, displacement means that when a new air comes, okay, it displaces the already present air in a system. That is displacement, right? Now cavity is that, let's say there is a ventilation here, so air will come and goes through the ventilation, it does not circulate. Okay, mixing means that there is proper circulation, that it's entering, then it is circulating inside the entire room, and then it's going out. And piston means that when you have these what you call force, when you force air into the system and you force air out of the system. Okay, that is what piston is. Piston means that you pushes the air, and uh, air will move from towards the system and out of the system. So for each and every scenario there will be a different sort of box model that can be used. Okay. Okay, now next is about the type of air cleaners. So in an indoor air environment, you need to have different purification technique, so that we can have a better air quality, at least inside the house. So there are two types of air cleaners. One is portable, another is high vac. So portable is nothing but just okay. Portables are when you carry the air cleaner. So the easiest example I would say, that in our household you have these air purifier, right? Where they have these different filters, and it what it does is it takes the air in, it purify the air, then put the air out. So it sucks the air in and then suck it out, or then push it out, and in between it has filters, so those filters clean the air. So that is portable one. So generally in household you have portable air cleaners. Next is high vac, which is heating, ventilation, air conditioning filters or devices. So this is heating, ventilation, heating, this is ventilation, and this is AC, air conditioning. So these are basically centralized system. Generally in universities and institute they have these, and offices have this HVAC system, where uh, they manage, if let's say if it's cold, then they heat the room. If it's hot, they provide AC, and they also have the pumps and filters to make sure that the air is being circulated inside the room or inside a particular place, enclosed space. Okay, so these are generally used in offices and buildings, like big infrastructure and all of that. Portables are generally used in our houses. Okay. Next is, what is minimum efficiency reporting value for filters. So generally a filter can have these MERV, or a filter can be HEPA filter also, what we discussed earlier. So this MERV is the so when they make filters, each filter have a different pore size, different um, size, like dimension and everything. So, and which filter is how much important or how much efficient is based on that how good the collection is. Okay, now MERV filters means their efficiency is from zero point 0.3 to 10 micron size particles. Okay, so this minimum efficiency reporting values varies from okay, so if a filter has a, pore size of zero point 0.3 micron, so there can be multiple filter with the same size. Now a filter is good means it has high efficiency. A filter is not very good means efficiency decreases. So the MERE value is that between two filters with the same pore size, okay, one of them can have a high MERV and one of them can have a low MERV. Let's say 2 and let's say 6. So it means the lower the MERV, the better efficiency or highly efficient a filter is, the higher sorry, the higher the minimum efficiency reporting value, the poor the quality of filter. Okay, so that is how we understand the minimum efficiency reporting value for different micron size filters. Next is about the photocatalytic oxidation unit. So, this unit is generally installed in houses, and the purpose of this unit is to basically, with the help of UV and voltage or the electricity, I would say, they would reduce the pollutant that are there in a house, especially organic pollutant, into carbon dioxide and water. So they have these UV lamps, and then they have these titanium oxide sheets or panels, and then these UV lamp will transmit light to these titanium panels. It generate oxidants. These oxidants react with the organic pollutant and it generate something called CO2 and water. Okay, and that is the function of photolytic oxidation. These are the unit that are used in houses to remove the organic pollutant. Mm, now this is last. Now, there, as I said, for the regions where there is high radon pollution because of soil, what happen is there is a technique called active soil depressurization technique. This technique will help in the radon removal. So, what it does is that in houses there is something called they have this pipe and they have this sort of what do you call it, a fan sort of a system at the ground, and this is a tail vent. So this what there is a fan sort of system towards the ground, and this fan generally circulate the radon and then transfer it through the vent. So what method I suggested in the radon mitigation system earlier, that method is this only, and it is called the active soil depressurization. It means that you have a circulation here, okay, and that circulation is helping radon to come out, and it's passing through the vent and is escaping. Okay, so next is the techniques that are used to remove PM 2.5 and VOCs from the indoor. So that is what we studied earlier also, which is one of them is photocatalytic oxidation, which is PCO, where organic pollutant with the help of the the titanium oxide sheet and UV lamp, they generate CO2 and water and get emitted out or the expelled from the household. Another is adsorption. Adsorptions are generally used or is done with the help of filters, or and those filters have, there are different type of filter, as I said in the previous slides also. There is MERV, different MERV filter, there is HEPA filter, and these filters have different type. For example, depending on their pore size, okay, their efficiency changes depending on their pleat size. That is how the more the pleat, there is more surface area. Okay, so based on the number of pleats of filter, the surface area changes or the efficiency changes. So the efficiency of filter depend on multiple factors, and those factors are also determine the adsorption, that how good an adsorber uh, a particular substance or filter is. There is something which is also discussed like chemisorption. Chemisorption is nothing but when you have something, some chemical sheets or chemical filters, and when a particle attached to it, it reacts here and it forms something. It forms a compound which is bound to the system, which is bound to the sheet. Now that compound cannot escape this barrier or this chemisorption sheet or filter, whatever. So chemisorption is nothing but when the sorption is due to the chemical reaction. And the last is that for microbes, so there is a sheet that okay, this technique is used for microbe, this technique is used for particles, this technique for the gases. So for microbe there is only one technique which is discussed, and I thought it's very important to understand, and that is UVGI. And it is very famous during the COVID time also, because it is UV, germicidal irradiation. This technique has UVA and UVC. With the help of these two radiation, what was trying they would try to do is that they try to kill the microbes. These UV radiations enter the microbe, decompose or dissociate its DNA and kill it. Okay, and that is why UVGI is the technique which is used for the microbe elimination in indoor air environment. Okay, so I think we are done for today. If you have any questions, if you want to know anything, you can ask. Good evening. Uh, I could not get your question. Can you like explain again? Exposure of pollutant. Your your voice is breaking. That's why I am unable to understand. Like I am hearing bits and pieces only. Can you write it? Just yeah, just write it. I'm unable to hear currently. Okay, how much exposure a person has to a pollutant is like okay. So see, you cannot identify that how much exposure will happen to a pollutant. You can always speculate. Okay, for example, if let's say in a particular region SO2 is being emitted at we know the emission factor. Okay, um, let's say here in a, let's say in a house I am burning cow dung cake. Okay, and from cow dung cake I know that how much different gases or different particulate matter is being emitted, and I know the emission factor of these particulate matter. Now we back calculate that okay, let's say a person is working, let's say a woman is working in a household and is burning cow dung cake for let's say past 5 years, and for every 1 hour burn of cow dung, this much particulate matter, this much SO2 is being released. All of these pollutant, how much they are being released after 1 hour burn of cow dung cake. And based on that, you back calculate that okay, for past 5 years, how much she was affected, and if this continues, if the practice continues, how much she will be affected. So you always speculate based on different parameters that are there, um, in your control, in your hands. So that, so even if you do medical test, you can know that okay, this person has, let's say, lung bronchitis. Yeah, so the epidemiological studies you can do, but for that you have to see first, you cannot do it on humans. You can do it only on rats or species which are like lung fluid cells and these things. So for that, you take a particular amount of pollutant, you inject it into rat cells, you put it into lung fluid, and then you see that okay, if, let's say, if every day I am putting 1 microgram of PM 2.5 to a lung cell, then after how many days or how many months or years it will get affected, and then you measure it. But the thing is that, again, those studies are also speculations, okay? Because because what you are saying is that I am making a culture which act like lung fluid, okay? But um, but let's say you take two different individual, one which is extremely healthy, has never had any pulmonary disease, okay, and one individual who works in a construction site, who also smokes, who has had disease, pulmonary disease, everything. And then you see that a same amount of exposure will affect them differently, okay? So epidemiological studies, or like normal mathematical or statistical studies that you do, they always give us the idea, but they cannot pinpoint that okay, if I put this much microgram is the amount that will affect, okay? You can always, and this amount also changes depend on the, if it's child, if it's a old age group, if it's women, if it's men, if it's a office worker, if it's a construction worker. So this value will also change. Yeah. Optical what? Optical? Huh. So optical sensors, see, so you are saying optical sensors are mentioned. What can you name? I don't recall it. What is there? See, okay. Optical, as the term says, optical means that you are using light to identify the particulate matter. Now, the simplest example is, uh, let's say, black carbon. Okay, black carbon is a type of particulate matter which has an which absorb among all the wavelengths. Okay, and we measure it using an instrument which we call as ethylometer. An ethylometer, what it does is that it has the particle coming, like it takes the air, the particles start depositing on the filter paper, then on that spot, on that 1 centimeter square spot, it transmit light, okay? It put lights of different wavelength, ranging from, let's say, 365 to 880 nanometers, seven different wavelengths. And then you s- it sees that okay, for each wavelength how much light is being absorbed by that filter and how much light is being transmitted. So that is what optical PM 2.5 measurement is, that you have different instrument which works on the principle of light and can tell you that okay, at what wavelength how much absorption is happening, how much light is absorbed, how much light is transmitted, and based on that you comment on the different particulate matter. For example, um, how much black carbon is there at each wavelength, or how much absorption by black carbon is there at each wavelength, you can comment on that. Where is it, where is it mentioned? Real time mass conservation, it it is, um can you tell me on which slide it is? I Real time mass conservation in simpler term could be that, which one? Okay, okay, wait. um, okay, it's a case study. Okay. Real times mean, okay, now I understand. So, for example, ethlometer also function on real time. Okay, real times mean that, okay, I'll tell you difference between two instrument and then you will be able to understand. So, we do two sort of measurement. One is real time, one is time integrated measurement. Real time means that if today, um, where the measurement is happening every minute or every second. Okay, for example, this is how ethlometer function, that it let the particle get deposited on the filter every second. Okay, so you have data for every second, that okay, let's say at 7 p.m, the concentration of the absorbance by black carbon is this. At 7:01, the absorbance is this. At 7:02, the absorbance is this. So what is happening is that at every 1 second, it's measuring a data. It's taking a data. Okay, that is real time measurement. Now, when we collect 24-hour or 12-hour sample, what we do is that we have this low volume or high volume sampler. We put the filter on, for we put the filter, we let it run for 12 hours, then we go collect the filter. So the filter has the deposition, but we don't know that it's a deposition of 12-hour accumulated deposition, right? It's not giving us that okay, what is the value at 8, or what is the value at 8:01, or what is the value at 8:02. It's giving us that okay, when you start the filter at 7 a.m. and when you stop it at 7 p.m., this is the total amount of particulate matter that is being absorbed, that is being deposited. Now there is another thing called handheld PM 2.5 measuring device. So that device actually takes data for every minute. So then those device actually give you, okay, at every minute what is the particulate matter concentration. So that is real time, when you are getting data for every minute or every second, integrated when you have the accumulated data for couple of hours. So yeah. Yeah. So see, fluid dynamics means that you are considering that the air that is going into an indoor environment is fluid, right? And dynamic means that you want to study that how this fluid is behaving. So you want to know that depending on the change in ventilation rate, depending on the concentration, how this fluid is how the air, or which has the pollutant also, is moving inside a particular room or a house. And computation means that you are speculating it, like you are computing it based on the different data or measurement that you have. Okay, you are not seeing it, or you are not just say, for example, uh, when you do this something called active sampling, you like in the advection model or simple modeling technique. So in advection, you know that how it's changing, right? That for you are seeing it physically, that okay, at 1 hour this is the data, at 2 hour this is the data. Computation means that you are not even there in the indoor environment, you are not even in the house. You are computing that if, let's say, let's say the dimension of a room is 1 by 1. Okay. And if, let's say, the flow rate of indoor air is, let's say, 2 centimeter cube or 3 centimeter cube, and if the speed of wind is this, so you have all the different parameters which you are setting, and then you are computing that, okay, how the air inside the room or inside the house will behave. That is computational fluid dynamics. Yeah. Okay. So if there is no doubts, we can end. um, Thank you everyone.